A common sign that someone is deficient in this particular vitamin can be seen on their mouth. Cracks that may be red or swollen on the corners of their mouth and dry, chapped lips are a sign of this deficiency. Other signs and symptoms: low energy levels and dry skin. In today's episode, we are doing episode 3 of our Vitamin Miniseries, only here on the People Scientist podcast.
You are listening to The People Scientist, the podcast dedicated to helping us optimize our health with the latest scientific findings on nutrition, health, and medicine. I, your host, Dr. Stephanie Caligiuri, a nutritionist, physiologist, and neuroscientist, will be here with you every single week, bringing us information to ignite our thinking to help us be one step closer to the healthiest we can be.
Hello, my People Scientist Army, and welcome back for episode 35 on the People Scientist podcast, where every week I arm you with some scientific evidence so we can all lead the healthy lives we want to live. This week on the People Scientist podcast, we are continuing our Vitamin Mini-series. As I'm recording this Vitamin Mini-series episode, I am sitting on the floor surrounded by a bunch of boxes because right now I'm in the middle of moving into a new apartment, which I am very excited about. But moving weekend is not going to stop me from posting a People Scientist podcast. So here I am recording sitting on the floor. The Vitamin Mini-series includes shorter episodes dispersed throughout the podcast that dedicates one episode to a vitamin. I share information on signs of deficiency, the function of the vitamin in our body, the highest food sources, those that may be at risk for deficiency, and any negative side effects to taking high amounts of that vitamin. So far, we have covered vitamin C and vitamin B1 thiamine. This week, we're going to cover some scientific evidence on vitamin B2, commonly referred to as riboflavin. So as we always do, let's get into some core takeaways. Vitamin B2, or riboflavin, is an essential water-soluble vitamin that we need to get in our diet regularly in order to maintain health. Riboflavin is very important for our energy levels, for repairing our DNA against damage, which has important implications for protection against cancer. Riboflavin is also important for heart health and skin health. The recommended intake of riboflavin is 1.3 milligrams a day for adult men and 1.1 milligrams a day for adult women. The highest sources of riboflavin in our food supply include liver, dairy products, fortified cereals, oats, quinoa, beef, mushrooms, and almonds, to name a few. But there are certain populations that might be more at risk for riboflavin deficiency. So keep listening on to find out those details. Riboflavin is in the category of the B vitamins. B vitamins have many similarities. In particular, they are important for our energy metabolism and therefore our energy levels. Riboflavin is essential for the synthesis of a class of enzymes called the flavoenzymes, for example, which include the flavin mononucleotide and flavin adenine dinucleotide. These flavoenzymes are essential for our energy production, for DNA repair, which is really important because damaged DNA that is not repaired may lead to cancer and mutated malfunctioning proteins. The flavoenzymes are also needed for protein folding, a process called apoptosis, and in general, our ability to maintain homeostasis, which is our body's natural set point. So you can imagine, based on the important functions of riboflavin in our body, that if someone has low intakes of riboflavin or has a deficiency, there may be some issues, for example, with their energy levels, their skin health, or even their ability to repair damage, DNA damage. Now, some signs of riboflavin deficiency, as published by Wilson in 1983, include low energy levels, low tolerance to exercise, exacerbated breathing or difficulty being able to breathe heavily, heart abnormalities, a sore throat, swelling of the mucous membranes in the mouth and pharynx. And another very common sign that I think most of us have seen before is chelosis, or also called cheilitis. Now, this is a painful inflammation and cracking of the corners of the mouth. You may also see angular cheilitis, which causes swollen red patches in the corners on the outside of the lips and chapped lips as well. You may also see inflammation of the tongue, or seborrheic dermatitis is a common skin condition that mainly affects the scalp. So, for example, riboflavin deficiency could also result in some dandruff and flaky skin on the scalp. It can also affect the oily areas of the body, such as the face, sides of the nose, eyebrows, ears, eyelids, and chest. So a riboflavin deficiency can certainly have some impact on skin health. Anemia may also be a result of riboflavin deficiency, meaning that you don't have enough red blood cells. So that can also result in low energy levels and tiredness and weakness. But this is also common to a lot of other B vitamins as well. Other more severe deficiency symptoms of riboflavin include night blindness, cataracts, delayed growth in children, migraines, and peripheral neuropathy. Low riboflavin intake during pregnancy may be associated with an increased risk of congenital heart disease for the infant. Having a deficiency in riboflavin that causes these types of symptoms often occurs in association with deficiencies of other vitamins as well, and has usually been attributed to someone eating a very restrictive diet. It may be more common than currently thought, as an estimated 10 to 15% of the global population has an inherited, meaning genetic restriction in their ability to absorb or utilize riboflavin. So some people might just be born with a certain inability to properly absorb or utilize riboflavin. It is difficult to know if you are one of these individuals unless you pay for a genetic sequencing test. Or if you notice that you have some of these signs of riboflavin deficiency that I mentioned, it's possible that you have one of these genetic alleles that interferes with proper riboflavin transport or absorption. There are many genes that are involved in riboflavin transport, or these flavoenzymes. So as a result, if someone is born with a loss of function allele for this gene, that would mean that these proteins do not work normally for them. Now, there are certain diagnosed disorders that have difficulties with riboflavin utilization, such as the Brown-Violetto-Van Leer syndrome, in which it is known that they lack a proper functioning riboflavin transporter. Symptoms of these genetic differences for riboflavin metabolism include exercise intolerance, heart abnormalities, muscle weakness, respiratory insufficiency, etc. However, if you were born with one of these severe genetic defects, it would certainly be known from birth. Because riboflavin plays such an important role in repairing damage done to our DNA, the role of riboflavin in cancer risk has been investigated in animals and observational trials. Now, cancer can start by our DNA becoming damaged. When our DNA is damaged, it is as though our body becomes confused and it starts to produce mutated proteins and cells. These mutated proteins and cells are what can turn into tumors and cancer. DNA damage can occur from, for example, UV sunlight, oxidative stressors such as air pollution, cigarette smoke, high sugar diets, and lipid peroxides that can occur, for example, from fried foods. Our body normally can repair the DNA damage that has occurred as a result of these stressors, but it is hypothesized that the DNA repair may be compromised in a state of riboflavin deficiency. In 1996, Webster published in the journal Cancer Letters that riboflavin is essential in the diet for reducing DNA damage induced by a carcinogenic chemical in rats. And when the rats were put back on a normal riboflavin-containing diet, the DNA damage was significantly lower. Van den Dock in 2005, in the journal Cancer Epidemiology, Biomarkers and Prevention, reported that the risk for colorectal adenomas, which are benign tumors in the colorectal area, were reduced by half in individuals taking in the most riboflavin in their diet compared to those taking the least. Now, the least was below the recommended amount of 1.3 to 1.1 milligrams a day. LaVecchia in 1998 in the International Journal of Cancer reported that in over 6,000 people a relationship between certain vitamins was seen for the risk of colorectal cancer. They noted that carotene, riboflavin, and vitamin C were all individually associated with lower rates of colorectal cancer. A higher intake of riboflavin had a 27% reduction in the risk for colorectal cancer versus those taking in the least amount of riboflavin. Now, the lowest quintile, or the least amount, was set as below the recommended intake level of 1.3 milligrams a day, and the highest quintile, or the greatest intake category, was greater than 2.23 milligrams of riboflavin per day. Bassett in the European Journal of Clinical Nutrition reported that out of all of the B vitamins, riboflavin intake in the diet was associated with a lower risk of lung cancer, specifically in current smokers. Those consuming the most riboflavin had a 47% lower chance of having lung cancer versus those consuming the least amount of riboflavin. However, the data is not always consistent, as Johansson in the journal JAMA in 2010 reported that riboflavin levels in the blood were not significantly associated with lung cancer risk. If anything, one statistical model showed an 18% reduced rate of lung cancer risk with higher riboflavin intake, so potentially still a protective effect, but the statistics did not reach significance because the results were too variable for riboflavin levels and lung cancer risk. Now, because riboflavin plays an important role in energy production, it has been hypothesized that riboflavin supplementation could potentially enhance athletic performance. Tremblay in 1984 conducted a clinical trial to see if riboflavin supplementation of 60 milligrams a day in athletes could improve their athletic performance as measured by a swimming test, treadmill test, and oxygen consumption during exercise. It is important to note that these athletes were not deficient in riboflavin. The supplementation with riboflavin did not alter their athletic performance or oxygen consumption. So, supplementing beyond the basic needs or requirement of riboflavin doesn't appear to enhance athletic performance. And this non-significant effect has been replicated in a few other trials with athletes. Our hypothesis is really that if someone has a deficiency in riboflavin and then increases their intake of riboflavin, it is likely to have an impact on their energy levels because it's helping them maintain a homeostasis or normal functioning. But if someone already has adequate riboflavin intake in their diet, it does not appear that supplementation over that will enhance athletic performance. Now let's talk about the food sources of riboflavin. The greatest contribution to the riboflavin intake in the U.S. adult population comes from milk and milk drinks, followed by bread products and fortified cereals. Other sources of riboflavin are organ meats. Milk is both a rich source of riboflavin and a commonly consumed food, but riboflavin loss occurs if it is exposed to light. So for example, if milk is stored in a clear container under light for a long period of time, then that riboflavin is likely to degrade. In animals, they have shown that riboflavin requirements actually decrease as carbohydrate intake increases and fat decreases in the diet. So then this begs the question, if we are doing the opposite, which is a trend right now, which is meaning eating a lower carbohydrate diet and a higher fat diet, does our riboflavin requirement increase? Well, it is certainly possible because we've seen this for thiamine, vitamin B1, but it has never been directly tested to see if riboflavin requirements increase with a lower carbohydrate diet. It is also important to note that high carbohydrate foods such as cereals tend to be fortified with B vitamins, but if people have cut these higher carbohydrate foods out of their diet, it is important to make sure to get a good source of these vitamins from elsewhere in the diet. So keep in mind, if you're following a low carbohydrate diet, maybe take a look and see how much riboflavin is in your diet and if you are getting the adequate amount. But let's look at some other food sources. So we do need to consume riboflavin regularly. However, we are known to make small amounts of riboflavin by the bacteria in our large intestine. Now again, the recommended daily allowance of riboflavin is 1.3 milligrams a day for adult men and 1.1 milligrams a day for adult women. Now, milk products do contain the largest source of riboflavin in the Western diet, which makes up about 51% of the riboflavin intake in preschool children. 35% of the riboflavin is obtained from milk in school children, and 27% of riboflavin intake comes from milk in adults. But how about some other food sources? Well, 1.2 ounces of beef liver gives the full recommended daily amount of riboflavin. 1 1/3 cups of fortified oats gives the daily amount. 3 cups of cow's milk gives the daily amount, but that is a lot of milk to drink in one day. And not to mention, beef liver is a very rich source of a lot of vitamins and minerals, but it also tends to be very high in cholesterol and can potentially increase blood cholesterol levels for people as well. So just keep that in mind. But let's talk about some other combinations of food that can help you reach your daily requirement for riboflavin. For example, 3 ounces of cooked chicken breast, 1 cup of grilled mushrooms, 1 cup of quinoa, and 1 cup of plain yogurt will get you the recommended amount. So if you combine all of those in one day, that'll give you the recommended amount. If you are vegan, 2 ounces of almonds, 1 cup of grilled mushrooms, and 1 cup of quinoa will provide the daily amount of riboflavin. Or 1 serving of fortified cereal often gives the daily amount of riboflavin as well. As I have referred to in the last Vitamin Miniseries episode on thiamine, many countries chose to fortify their cereals and flours with B vitamins because, as you can see, it does take effort to obtain adequate B vitamins, especially if you are not eating fortified grains and if you're not eating dairy products either. So especially if you're eating a low carbohydrate diet or a restricted diet, it can be hard to obtain adequate levels of riboflavin. So please do make sure to try your best to include some of these rich sources of riboflavin that I mentioned. Again, one additional note about riboflavin is that it is light sensitive, meaning that when foods rich in riboflavin are exposed to light, riboflavin will degrade and break down. So just keep that in mind with the foods that you are consuming. Now, you may be interested in supplements for the B vitamins, but can we take too much riboflavin? Well, there is actually no tolerable upper intake level set for riboflavin, meaning that there are no negative side effects that have been observed or reported for high intakes of this vitamin. This is likely because the ability of our intestine to absorb riboflavin is limited, and because it is a water-soluble vitamin, excess will be eliminated via our urine. In supplements, if you take more than 1 milligram a day of riboflavin, the amount of riboflavin in your urine starts to increase. So the body will remove the excess after 1 milligram of intake. One kind of interesting side note, have you ever wondered why, after taking a multivitamin or a B vitamin complex, why your urine is brightly fluorescent yellow? That is because of riboflavin. Riboflavin itself is actually fluorescent and a bright yellow color. So the next time you take a multivitamin and notice that your urine is a different color, you'll now know that it is probably because of the riboflavin in that supplement. So that is a wrap, my People Scientist Army. This was episode 35 on the People Scientist podcast, but episode 3 of our Vitamin Mini-series, where I cover some scientific evidence on one individual vitamin for each episode. Today we talked all about vitamin B2 riboflavin, which is very important for our energy levels, for our skin health, for our heart health, and potentially for protection against cancer. Keep in mind that if you are not eating fortified foods, that it may take some effort to obtain adequate riboflavin from your diet. If you have low energy levels, cracked corners on your mouth, or chapped lips, dry skin, dandruff, it is possible that it could be because you are riboflavin deficient. So make sure to eat some of those high sources of riboflavin that I mentioned earlier in this episode. I hope you all have a super healthy week, and I look forward to meeting you all back here the same time and the same place on the People Scientist podcast. Bye for now. I am a scientist simply sharing scientific evidence.
Some of the clinical interventions I discuss are not appropriate for everyone. Before making any changes to your diet or lifestyle, please do consult the advice of your physician or dietitian. My opinions expressed here do not necessarily reflect those of Mount Sinai Hospital and its affiliates.